Okay, grade 7. This is section 7.2 of the MathLink 7 book. This is on adding fractions that do not share common denominators. So in our first question there, I'll show you we have what is 1/6 plus 2/3. Now we know from the last chapter when we were adding fractions that had common denominators, it was easy to add, let's say, something simple like 1/4 plus 1/4, because we simply had to say if we have 1/4 plus 1/4, we would have 2/4 in total, which in lowest terms was a half. But the problem with this section is that when we're talking about 1/6 plus 2/3, they do not have the same denominator, which means they're not the same size piece, which means we have to actually create equivalent fractions to each of them that share a common denominator. So the first thing we have to do, and that's step 1, is we have to find what multiples both 3 and 6 share. So if I was to write the multiples of 3, I could keep going for a long time. I can go forever, but I'm going to stop at 18. And if I was to write the multiples of 6, I could also go forever, but I'm going to stop there. And if we look at the multiples of those two, the ones that both 3 and 6 share, they both share the multiple of 6. They both share the multiple of 12. And if I was to keep going here, 3 would also share the multiple of 24, but they share the multiple of 18. And they would share 24 as well. But they share those multiples. Now, what does that mean? That means that those numbers are, you can create equivalent fractions with those for each of them so they can share the same denominator. So if I look at 6 is the lowest common multiple they share. So what I'm going to do is I'm going to create equivalent fractions to each of those. So instead of saying 1/6 plus 2/3, I'm going to create a statement that says 1/6 plus whatever 2/3 is as an equivalent fraction. And if I was to draw 2/3, that's what it would look like. And if I was to change that into no longer parts of 3, but parts of... So as we can see here, right now we have 2/3, but if I put a cut here, I don't change the amount of shaded area in my rectangle. I just shade how many parts there are. So there were 3, but now there are 6. And we can see from this drawing that there are 4 parts out of 3, which means that 2/3 and 4/6 are the same number. But what we're going to do here is we're going to write 2/3, and I want to say how many 6 is that? And the algorithm is to figure out what did you multiply 3 by to get 6. You multiplied by 2, and therefore you're going to multiply the numerator by 2 as well. And really what this represents is how many new parts you made. When I made a cut, I made 2 different sections, right? So that's why you're multiplying it by 2. You're doubling the amount of shaded area, and you're doubling the amount of parts in total to create 4/6. So 1/6 plus 4/6 would be the same thing as 1/6 plus 2/3, which we would add the numerators and keep the denominator. Our answer would be 5/6, and therefore 1/6 plus 2/3 is also equal to 5/6. If we extend this and go to the second question says 1/10 plus 4/5. So again, if we look at our multiples of each of them, pretty soon we're going to see the first multiple they share is actually the number 10. So we're going to use that as our lowest common denominator. And I'm going to put 10 here and 10 here. Now of the 2 fractions, the first fraction is not going to change. It's going to stay 1/10. And 4/5 is going to become a different fraction that has the same value. So I multiply 5 by 2, 4 by 2, we get 8/10. And if I was to draw 4/5, just to show you, there's 1/5, 2/5, 3/5. There's 4/5. If I was to change those into tenths, I could cut it right here, and I would show 8/10 is the same amount as 4/5. So we'd put 8/10 up here. Add the numerators, keep the denominator. My answer is 1/10 plus 4/5 is 9/10. And in the last example, one more. No. Heavens to Betsy. There we go. In the next one we have, in the last one we have 1/2 plus 4/8. And this is actually quite an easy one because instead of doing 1/2 plus 4/8, I don't have to say 4/8 because I know that 4/8 is really the same thing as 1/2. So I could reduce 4/8 to lowest terms, and a half plus a half everybody knows is 1. So therefore I know my answer is going to be 1. But just to see if it does work, I'm going to change these to equivalent fractions. The first multiple that 2 and 8 share is 8. 4/8 is going to stay that way. 1/2 is equal to how many eighths? The answer is it's equal to 4/8. 4/8 plus 4/8 is 8/8, which we know is still 1. Okay, that's the first show you know. If you turn the page over, we have a second set of show you knows, but this time we're dealing with subtraction. So for this one, same process as addition, just a little bit different towards the end. So the first show you know we have is 3/4 take away 1/2. So we're going to use the same process. The first multiple both 4 and 2 share is number 4. So we're going to find an equivalent fraction to 1/2 that has a denominator of 4, and the equivalent fraction that is equal to 1/2 is 2/4. 3/4 take away 2/4. We subtract the numerators and keep our denominator. Therefore, our answer is 1/4. And again, if I had 3/4, 1, 2, 3, and I was to take away 1/2, I would have to take away this half right here. That's half of the chocolate bar. I would be left with 1/4. In the second example, we have 2/3 take away 1/4. The first multiple both 3 and 4 share is 12. So I'll write down 12. 2/3 is equivalent to 8/12. They're the same amount. So I'm going to write down 8/12 instead of 2/3. And instead of writing 1/4, that's equal to 3/12. So instead of saying 1/4, I can say 3/12. So instead of saying 2/3 take away 1/4, I can really say 8/12 take away 3/12. And 8 take away 3 over 12 will be 5/12 is your answer. And if I want to draw that, here's 8/12. So there's, oh, that's not right. If I draw a chocolate bar and there's half, I go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There's 12 parts. If I shade in, I think this is right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, that works. So that's 8/12. And if I take away 3/12, I would have to take away these 3 here. And I'd be left with 1, 2, 3, 4, 5/12. So 8/12 take away 3/12 is 5/12. And the last, is that the last question or the first question? That was the last question? No, the last question is 3/4 take away 1/8. So when I examine my multiples, the first multiple both share is the number 8, so I'll use that for my common denominator. 1/8 won't change, but 3/4 is equal to how many eighths? The answer is 6/8. So I'll put that here. 6/8 take away 1/8 is the same answer as the last one. It is 5/8.